The principles of linear superposition and interference are among the most interesting and applicable principles that we'll talk about all semester. They form the basis for Western music. And we'll talk about linear superposition, which is where you take two waves and they're overlapping with each other. And we'll talk about both constructive and destructive interference. Constructive, where they actually add together, and destructive, where they cancel each other. We'll talk about diffraction, wave diffraction, bending of waves around corners, beats, which is the way that musicians tune their instruments, transverse sound waves, and these are standing waves. Transverse standing waves are where we have two waves on a string at the same time that combine together to form a standing wave. Looks like it's not going anywhere, that's why they call it a standing wave. And that's the frequencies that we'll see in those transverse standing waves will introduce us to the idea of the harmonic series, which is the basis for all of Western music. We'll talk about longitudinal standing waves. These are standing waves in a column of air rather than on a string. And then we'll also talk about complex sound waves, which is where you add up different harmonics to get a more complex sound. First section is on the principle of linear superposition. It's where we're adding two waves together. Let's first look at a video. And what we'll see in this video is two pulses created, two peaks that are created on the left and the right hand side of a wave, and then they come together, and I want you to watch and see what happens when these two pulses hit each other and then pass through each other. Okay, I think you see that they combine together to form a bigger pulse when they came together. This next clip will freeze them right when they overlap with each other. Okay, so they're overlapping now with a larger peak than either of the individual ones. And then one more time. Okay. So what we've seen is two pulses coming together, forming a bigger pulse, and then heading right on out once they're done. So now what we're going to do is look at the case where we have one positive pulse and one peak, and then a negative pulse, and see what happens when they come together. Now this next clip will freeze them right when they're overlapping each other. So what's happened here is that the positive one has canceled the negative one. Now watch it again as they pass through each other and then continue on. The negative pulse just kept right on going. The positive pulse also just kept right on going. So it's not so much the idea of interference as it is superposition. That's what we call it, superposition. And they cancel each other as they pass. So when two or more waves are present simultaneously at the same place, then the resultant disturbance is the sum of the disturbances from the individual waves. That's why we call it linear. Whenever you can add two things up, we call that linear in physics. If you can't just add them up, it's called nonlinear.